we're ready to begin. And we're on the last section of our review chapter here, and yes, it's everybody's favorite topic, factoring. Woo! Okay, we're going to go back through the basic factoring rules that we've done before. There are a couple problems at the end that are maybe a little different than what you've seen before. However, regardless of how many terms you're attempting to factor, there's a first step you do on every single problem without fail, because it can make your life so much easier if you notice this. And let me give you an example here. If I gave you 30x to the fourth minus 42x squared, what would you do? What can you notice you could do as you look at that? Well, hopefully somebody out there is going, hey, 30, 42, they have a common factor. X's, I have X's in both, that's a common factor. So yes, I can pull a 6 out, and X's I can pull out the smaller power, which is x squared. Now once I pull that out, what will be left? We'll take 6 out of 30, you got 5. Take x squared out of x to the fourth, and you have an x squared left. Over here, 6 comes out of 42 and leaves us with 7, and the entire x squared would be gone. Now you look at it, you may be done, but maybe what you have left in that quantity is factorable. In this case, a 5 and a 7, not too likely. So in this case, we would have to leave that one right there. But looking for common factors is always a crucial thing to do. Okay, the rest of factoring comes down to how many terms you have. I'm actually going to do this in reverse order. Matters whether you have 4 terms, 3 terms, or 2 terms when you're trying to factor. Most of you in previous years have thought that 4 terms was actually pretty easy. And it goes right along with this. Let's pull out the common factor. So in the case, though, of the 4-term one, you're going, well, there's not a common factor in all 4 terms. But hopefully, we are seeing that, remembering that 4 terms, I can also use our favorite method, grouping. If there are 4 terms, grouping works. Well, I should say guarantee it works. Grouping is the method that might work. Actually, there are many 4-term expressions that wouldn't be factorable. But when you group the first 2 and you group the last 2. Be sure when you group the last 2 that you include the sign on that 3rd term. So as I look at the first 2, just the first 2, ignore the last 2. What's in common to just the first 2 terms? Well, 6 and 10 would have 2 in common. And how many k's could I pull out? Well, yep, looks like I could pull out k squared. So if I pull out a 2 and a k squared, what would be left in there? Well, that would be a 3k, would be left from the 6k cubed. If I take 2k out of 10k squared, I would have 5 left. The k squared has been pulled out. So I really have the quantity 3k plus 5. Now you go do the exact same thing on the second pair. What's in common to 27k, negative 27k, and negative 45? Well, yes, negative 9 would be in common. There's no variable, but we'll take negative 9. So if you're pulling out negative 9, that's going to leave you with a positive 3k. And if you're taking negative 9 out of negative 45, it's going to leave you with a positive 5. Now, hopefully, you're noticing the miraculous event that has occurred. Yes, the 2 binomials that are left are the exact same. That has to happen. If they aren't the same, this method doesn't work, and it's probably not factorable. So 3k plus 5 has to be, in this case, in both of them. Now, this is the part people have trouble visualizing. The next step, you are never done. Grouping takes 2 steps. That's important. There's always 2 steps when you group. This was step 1. Now you go, okay, I have this clump of stuff before the subtraction, then I have another clump of stuff. What is in common between those two clumps? Well, both clumps have the quantity 3k plus 5. So what I'm doing is I'm pulling 3k plus 5 as a common factor. 3k plus 5 is moving out front, and I am left with 2k squared minus 9 then. Now I am down to two factorable binomials. And as I'm sure you will remember from Algebra 2, factoring helps us solve many, many, many more problems. So it's crucial that we know how to factor. And that, in this case, you could check 2k squared minus 9, do you think it would factor farther? In this case, it doesn't. But on a very rare occasion, you might get something out of grouping that does factor farther. So that was 4 terms. Now we're going down a step. We're going 3 terms. Okay, 3 terms you've done in your slate 15,000 times because it's the bottom step of many, many other algebra problems. When you want to solve a 3-term expression, what do? Yes, you unfoil it, or it's the same thing as saying you factor it into 2 binomials. Whichever one of those rings better with you. But unfoiling is really great, but of course it's giving me trouble here. All right, so 3 terms. Once again, first check, is there a common factor here of these 3 terms? 15, 14, and 8? Nah. So we are just simply going to unfoil it in 2 binomials. And if you recall, this is just a matter of trial and error. You got to play with it. So your guess, what factors of 15 are we trying? 1 and 15 or 5 and 3? Usually it's not the extremes, so I'm going to try 5 and 3 here. And now I have to do the factors of 8. So do I think it's 1 and 8 or 2 and 4? Well, once again, if I use an 8, it's going to make me have some awfully big numbers. So I'm probably going to back off 8 for the moment. And I'm going to try 2 and 4. Okay? If we're going to try 2 and 4, then we're going to have to just play around with it. And I want you to see that it is just trial and error. So I'm going to say, suppose I try 4 and 2. Who remembers how you check to see if this is going to work? Well, hopefully you're going, yes, you check the inners and the outers and see if you can get it to make a 14. So 4 times 3 would be 12p. The outers would be 10p. Is there any way we're going to get a 12 and a 10 to make a 14p in the middle? Nope, I don't think so. So, okay, that means we guessed wrong. So I'm going to, in this case, it's easier to undo here. I'm going to try it the other way around. Maybe it should have been 2 here and 4 on the back end. Now try checking your inners and your outers. Inners make 6p. Outers make 20p. Can a 20 and a 6 end up being a 14? Yes, if we subtract them. And of course we know here that since we have a negative 8, we have to have one sign, one positive sign, one negative sign. So I know in this case, since I want a positive 14, I need positive 20 and negative 6, which means I have to put the negative in the first parenthesis, and I have to put the positive in the second parenthesis, and that will now work. Later on, as always, we'll solve trinomials, we'll set them equal to 0, but in this case, we're just factoring, so you're quitting right there with the factors. Okay, this second problem has some rather large numbers, but once again, it's 3 terms and there's no common factor. But you should be noticing 16 is a perfect square, 9 is a perfect square. That's kind of suspicious. A lot of times when you see that happen, it's telling you that, oh, they want me to use 4m and 4m, and 9 would be 3 and 3. Since the entire problem is plus signs, I know I have to be using pluses. Now check your outers and your inners. Outers make 12m, inners make 12m. Is that gonna add up to be 24m in the middle? You bet. So in reality, instead of writing it as 4m plus 3 and 4m plus 3, that's really the same thing as just saying, oh, I got 4m plus 3 squared. That was a squared binomial. All right, I have saved the challenging part for the last part, and I want to check time here if I can, but it's not giving me the option to check the time. You just gotta love it. So we're going to get through these two-term expressions, and then we'll take a break and do the short piece at the end here. Actually, no, we're not, because my phone is ringing, so we'll pause.